Next is electric field on the axis of a charge carrying loop. We have a loop with center O, radius A, positive charge placed in YZ plane, and observation point is on x-axis at a distance x. Here the charge is Q on the loop. To find the electric field at point P, consider the small element AB with center of length dl and charge dq. Due to this, the electric field is dE vector theta, this is R, and R is a square plus x square root. This dE resolve into two components, dE cos theta and dE sin theta. If we have diametrically opposite element with same length, then the electric field due to this point is dE dash vector angle theta, and this component is also resolved dE dash cos theta and dE dash sin theta. Now the magnitude of dE vector and dE dash vector are same, that is 1 over 4 pi epsilon naught dq upon this Cp square or R square. These two components cancel each other and they added to give the electric field. Similarly, any other two diametrically small element whose sine component cancel out and cos component give the total electric field. So the total electric field is dE cos theta for the total loop, where this cos theta is x upon R, x upon a square x square root, and total electric field, this charge dq is equal to lambda dl, and lambda is q upon 2 pi a dl. Now to calculate the total electric field, E is equal to 1 upon 4 pi epsilon naught. In dq we have this value q upon 2 pi a dl, and in cos theta x upon 2 pi a, and this r square also, this r square, that is a square x square, and cos theta x upon a square x square. So electric field become 1 over 4 pi epsilon naught qx 2 pi a square x square 3 by 2 integral dl, and this integral dl is 1 upon 4 pi epsilon naught qx 2 pi a square x square 3 by 2 into 2 pi a. So our answer become 1 over 4 pi epsilon naught qx upon a square x square 3 by 2. This is the electric field on the axial point of the this charge loop. If this point consider at the center x0, then electric field become 0, and if far away distance काफी दूर ले जाइए इसे, then x square is very large than a square. Neglect a square. But we got electric field is neglect करता है a square. Q upon x square means the electric field of point charge. It means for a charge loop, when the observation point is very far away, then this loop is considered as a point object. This loop is considered as a point object. Okay. Now, next is electric dipole. Dipole means two equal and opposite charges separated by a certain distance is called a electric dipole. minus q plus q charge with center O and distance 2a vector, that is from minus to plus, and we have a dipole moment q into 2a vector, that is again from minus to plus. This is the axial line x, point P. Let's we have this distance A, and this is R, point A, point B. Now due to this, because the electric field is inversely proportional to distance, due to this charge, the electric field is towards PA and small in magnitude क्योंकि distance ज़्यादा, and for this EB vector नेड़े होने करके, and this is the net electric field. Then EA 1 over 4 pi epsilon naught Q upon R square means P A square R plus A square along PA, and EB 1 upon 4 pi epsilon naught Q upon R minus A square along BX या PX, and the net field is EB magnitude is large than EA Q upon 4 pi epsilon naught R minus A square R plus A square, but we have Q upon 4 pi epsilon naught R square A square whole square R plus A square R minus A square. By solving this, we have the value 4RA R square minus A square whole square, and Q into 2A is P, so electric field become 1 over 4 pi epsilon naught 2PR upon R square A square whole square along PX, and in vector form it is in this form. And if the dipole is short, then neglect this A square, neglect, dipole is short, then electric field become 4 pi epsilon naught 2p upon r cube. E is proportional to r cube. This means the symmetry, the electric field has cylindrical symmetry for the dipole, because this means the electric field has, in for point charge, the electric field has a spherical symmetry. For the next, that is on the equatorial line. Equatorial line. How we calculate on equatorial line? That is minus q plus q. Center, this is equatorial line, point P, that is the equatorial line. L length, distance L length या आप बोल सकते हैं A length 2A vector A length, dipole is Q into 2A or A length. Then electric field due to this point A B, that is EB vector, and this is EA vector. This is angle theta, this is angle theta, 2A vector. Now, if they represent parallelogram sides, this is the net electric field, that is E vector, or we can say theta, theta. Now we have the method that this EA, again the two components, EA cos theta, EA sin theta. If I consider point P, this is EA and this is EB at angle theta. So this becomes EA cos theta, EA sin theta, and this EB cos theta, and here EB sin theta. Charges are same, distance is the same, then magnitude of electric field is same, and the net field is this total electric field, in this case 2EA cos theta. Then how we write this EA, that is 1 upon 4 pi epsilon naught q upon r square, means r square plus a square, and cos theta. Cos theta is a upon r square plus a square square root q into 2a, that is equal to dipole moment P. Then electric field become 1 over 4 pi epsilon naught P upon r square a square 3 by 2. That is due to the equatorial point. And if we put the vector, here is negative sign, because this dipole moment is always from negative to positive. But this electric field is from positive to negative charge, so negative sign. And for short dipole, again we have 4 pi epsilon naught P upon r cube. This is the electric field by using the at the equatorial point. And if we have the article that electric field at any point, not on the axial, not on the equatorial, at the short dipole. Short dipole. This is minus q plus q O point. Now this is the observation point at angle theta. This is A at angle theta. This is A. Now here, how we calculate the value of electric field at P due to the minus q and plus q charge. Here we know that dipole moment is a vector quantity and it acts along this angle. Dipole moment is P cos theta, dipole moment P vector, and to perpendicular direction it is P sin theta, AB vector, AB dipole. If we have this AB dipole minus q plus q, observation angle theta. Now here, this is the P vector. This is our observation point. This is not dipole moment. Dipole moment is P vector. It resolves into two components, P cos theta and P sin theta. P sin theta. So we considering here कि ये डाइपोल ही दो हिस्सों च रिजॉल्व हो गया, एक A1 B1, A1 B1 whose dipole moment is P cos theta, and the second is A2 B2 whose dipole moment is P sin theta. So now we considering it the two dipoles. Our observation point is A1 B1, observation point axial line E1 vector. In last article we considering that minus q plus q axial line electric field, and here it is equatorial line E2. And in equatorial point, how we calculate the electric field? Parallel to the dipole, parallel to the dipole, and axial along the dipole. So here we get the resultant electric field, that is E vector. This is the resultant electric field. Now it is a short dipole. So due to A1 B1, E1 is 1 by 4 pi epsilon naught 2p cos theta upon r cube, 2p cos theta upon r cube, and due to A2 B2, E2 is 1 upon 4 pi epsilon naught p sin theta upon r cube, जो last articles prove हुआ, and this is the parallelogram at an angle of 90 degree. So this electric field become E1 square E2 square, that is 1 upon 4 pi epsilon naught 2p cos theta r cube square plus 1 upon 4 pi epsilon naught p sin theta r cube square. Then what we have? 1 upon 4 pi epsilon naught, what we common? P, this P and r cube, and here 4 cos square theta plus sine square theta, or we have 1 over 4 pi epsilon naught p r cube 3 cos square theta plus 1. This is the resultant due to this short dipole. And for calculating the direction alpha here, tan alpha is E2 upon E1. And if we divide this E2 value by this E1, everything is crossed. Only sine theta upon 2 cos theta means 1 by 2 tan theta. This we have the direction. And now, when the dipole is placed in a uniform electric field, then what is the resultant on it? Uniform electric field. Now this is parallel spaced lines that represent the uniform electric field. Here we place the dipole electric field minus Q plus Q AB electric field. The length is 2A, not the 2L. At the starting of this lecture, I think I take the 2L. That's not, the dipole has the length 2A. This is at angle theta. Now, the force due to this field at point A minus QE vector, negative charge, minus QE vector, and at B in the direction of electric field. Two equal and opposite forces means when the dipole is placed in a uniform electric field, it experiences the two equal and opposite forces. So the net force is on the dipole is 0. Then it gives the torque to it. This is P vector. Torque means perpendicular distance. AK, line of action between the two forces. Perpendicular distance, it is angle theta. And this theta is sine theta, that is AK upon AB. And this AK is AB sine theta or 2A sine theta. So now the torque is either force into perpendicular distance AK, that is the torque is QE into 2A sine theta. Now Q into 2A is P, so the torque is PE sine theta, or tau vector is P vector cross E vector. Means when a dipole is placed in a uniform electric field, net force is 0, but it experiences a torque that is equal to P cross E or PE sine theta. And when this theta is 0, means when the dipole is placed parallel to the uniform field, then it is in stable equilibrium. And when it is placed at 180 degree and sine 180 degrees again 0, P vector is anti-parallel to E vector, then this dipole is in a unstable equilibrium. And when it is placed in this uniform electric field, there is a potential energy of the dipole. Potential energy of the dipole. Then how we get this potential energy? To calculate this, to potential energy to calculate. That is we have, when the dipole is placed, it is PE sine theta. The torque exerted is PE sine theta. And for the small work done, tau d theta, that is PE sine theta d theta, and total work done PE integration, that is theta 1 to theta 2 sine theta d theta, sine theta d theta, and this will be okay. So work done PE, and the integration of sine theta is minus cos theta, theta 1 to theta 2, minus cos theta, and work done minus PE, that is equal to cos theta 2 minus cos theta 1, cos theta 2 minus cos theta 1. This work done is stored as a potential energy of the electric dipole, that is cos theta 2 minus cos theta 1, the electric potential energy of the dipole. If initially the dipole is aligned to the parallel of electric field, that means theta 1 is 0, and we have to considering it parallel and set it to theta 2 equal to theta 2 is equal to at any angle theta, then this potential energy is written as, or we say work done is written as minus PE cos theta minus cos 0, and the work done will be minus PE cos theta minus 1. We can say that this is also, this work done is again the potential energy. And if the dipole is initially placed at an angle 90 degree, and it have to place in a, placed at this theta 1 is placed at 90 degree and theta 2 is again theta, then what we got here, we got this work done is a minus PE cos 90 minus cos theta, or minus PE cos theta. So this potential energy is a minus PE cos theta, or U is a minus P vector dot E vector.